with this panel. My name is Babak Seradjeh of Indiana University, so I'll be your moderator for the next hour or so for this panel, which is focused on international practices of reproducibility and scientific integrity. We have a distinguished panel, but I think more than distinguished, they're also experts, and they have a lot of experience with the topic from various perspectives, which is relevant to the focus on of the panel. So our panelists are Vincent Moric from Juelich, the research center in Juelich, Frank Marcilio from University of Alberta, Beth Masimore from the National Science Foundation, Office of Inspector General, Yustina Zak from NIST, and Dan Dahlberg from University of Minnesota. So each of you will have a chance to do a little introduction. I know that some of you have some slides, so I will share those. But you know, even without slides, you can, of course, introduce yourself and perhaps tell us as part of that introduction, what is sort of your experience and perhaps one of your earliest experience with reproducibility issues, and tell us a little bit about that. So we'll start with Vincent. So you have some slides.
So the basic question, and it's kind of fortunate that I'm the first, I think, in that sense. I wanted to ask a question: why should we care about reproducibility in condensed matter in our community? We can immediately go to the next slide. Because, you know, it's an effort, and typically, yeah, I have this image of an old professor's office that you walk into, you ask for data, and the person basically starts ranting. Like, the person is unhappy that you dare to even ask to distract him from his big team, and yeah, just wants you to go away. So in my opinion, there's basically a retrospective element to that, the aspect of verifiability and accountability of our research, but there's also a prospective aspect to that, and namely the reusage of our results, reanalysis, meta-analysis. I think in our community that is not very common yet, but I don't see a principal reason why we wouldn't be doing it. I just don't think we have the means to do it. So next slide, please. Yeah, so, and this is really the point I want to make here, that is the format that we share our results right now, the published paper format. It is by no means sufficient, in my opinion. A paper is nothing more, in my opinion, than an illustrated essay, a number of heavily processed figures. Really, it's better to call them often images or cartoons with a nice story going with it. But the product of our work, of our scientific work, is so much more than that. It is an entire workflow that we go through, and there are so many aspects of it. There's raw data. It can have many different forms. It can be numerical, but in the samples are part of the raw data, etc. Procedures that we follow, they can be documented through all sorts of measurement scripts, etc. There's specific analysis to say something more meaningful about the raw data, often documented in scripts or calculations based on the data. And in the widest sense, even communications with the outside world are part of our output and our work. So how we engage with the public and with journalists. And I'm of the opinion that currently we don't have an integrated tool available to us scientists that we could use, like going in the lab tomorrow, to log all this in a systematic and usable fashion. So this is something that I want to think about and work on in my own team right now while we are building up it. For example, I'm trying to make some progress on this topic and try all this. Yeah, thank you.
Thank you.
Okay, so my name is Frank Marcilio. I've been involved in the high pressure hydrides. All of that work has actually been done with Jorge Hirsch. I would go further than that. I don't think it's an exaggeration that I was dragged into this kicking and screaming. It's not something that I think any of us really want to get involved with. And but I did get involved. In fact, six days after the Nature 2020 paper from the Rochester group appeared, we submitted a comment to Nature that eventually got published later on because we noticed anomalies. I shouldn't call them anomalies. Unusual behavior. In particular, the resistance curves were very narrow, especially when you apply the magnetic field. So this was the perspective of two theorists who I think we can say we were very knowledgeable in the field of superconductivity, and it was apparent that these investigators were not so knowledgeable in superconductivity. They were coming from the high pressure end of things. So let's go to the next slide. So I was involved in a series of papers with Jorge, but on the side, what eventually emerged, and at least as far as I was concerned, it wasn't clear at the start, was oh, sorry, yeah, let's move. Yeah, I'm going to focus on these are some of the suggestions provided to us, and I'm going to focus on a few of these. So let's move to the next slide now. For this, so I was saying that what emerged was an investigation carried out primarily by Jorge on his own. I was not involved in this, and then Dirk van der Merel joined up with him and discovered that that there was manipulation of data involved. So one of those questions was, what are the examples of best reproducibility practices? And here's one where this is an example, and we've discussed this here about having these repositories and so on. They're going to be useless unless there's some enforcement that these are valid data sets. So through the persistence of Hirsch, eventually two of these authors released raw data, which I put in quotes. James Hamlin already mentioned these tables. There's 149 pages of these tables that you basically have to transfer the numbers by hand. So it was largely discouraging anybody from doing anything with this data. But Hirsch was persistent and looked at all of this. The other thing that was wrong with this data was it wasn't the complete set of data. But you sort of know the story by now. In this paper and in subsequent papers, if you go this and then the next one, they basically unraveled what was going on with this. But I use this as an example where we have to be careful when we ask for a record of the raw data. It has to be a complete and useful record in order for people to make use of this. 99% of people who might have thought of looking at this more closely would have been immediately discouraged by the simple format of this data table. Okay, so if you move, so this is very important, and I don't want to belittle it, but it's almost a distraction in my mind from maybe what is part of the focus of this conference, which is not the falsification of data, which is, like I say, it's a part of it, but it's a distraction from the reproducibility. There's a lot of obscuring going on, a lot of not showing everything that should be shown, and that I think is what is plaguing this field at the moment. So I've been involved mostly in not working necessarily with the results from DS that were kind of discounted very early on, at least in some of our eyes, but with the rest of the field, which has, it's specialized. There's diamond anvil cells involved. There have been very few, for example, magnetic susceptibility measurements, and people have not been willing to release raw data. And we've been criticized, I feel, for questioning the authorities in this matter. But I'm very grateful for Stuart Brown's talk on strontium ruthenate, because you could not have a better example of two very well-respected authorities who, back in 1995 or whenever it was, presented the facts, so to speak, based on the data available at the time and the theory. And it was a good story, and it was something everybody believed. But we should never discourage people like us, in this case, from digging deeper and looking at possible alternatives and really seeing if the experiments support the evidence for whatever theory is going on there. And that's what we've been doing, and what I feel hasn't been so well received, because in part the people we're criticizing, or of whom we're asking a little bit more information, are fairly reputable. But that's not a reason not to do good science. Okay, and I think, the other part that I wanted to touch upon was another question about education and training. And, we're all old dogs, and you can't teach old dogs new tricks. I think we have to focus on the younger generation. And I, for one, felt when I was younger, I was raised in science in a culture that, that really wanted minimal information. Journals, referees, editors were all demanding shorter papers and less information for reasons I never fully appreciated. Now that we've gone mostly electronic, I think some of those reasons are gone. So we should encourage as much information to be laid down in a tractable way as possible. That was a bit long-winded, but I'll stop here. Yeah.
All right. Thank you, Frank.
Skip my slides. I don't need slides. I'll
Okay.
skip
Yeah.
everything.
Go ahead, Beth.
I think the previous half hour was the primary introduction, as for most of you, but just one or two additional points to respond to the question of sort of what led me to being here. In addition to just the job that I do, I'd back up, and because I want to use this as a point, I serve as the liaison between Office of Inspector General and the directorate at NSF that is math and physical sciences. And I say that to emphasize that it's a very broad field. I got a question from someone earlier, like, do I ever work on cases that aren't condensed matter physics? And I'd say it's actually, when there is a condensed matter physics case that comes up, it tends to come my way. My coworkers do not fight me for these cases. But at the same time, it's just a small piece. We are 5 scientists that handle the entirety of the science that is funded at NSF. And I say that for a couple of reasons. Is because of that is when I do end up, if someone comes forward with information or if they make public reports, I am in all likelihood going to contact that person to be able to just ask you a few questions. And I've been very thankful for people, some of you in the room who have fielded those. Thomas gets my questions first because he's within NSF. And I'm just emphasizing that at this point, I'm acting as a generalist. I am never making specific scientific decisions, but it's through my connections with math and physical sciences and condensed matter physics. And while it was a long time ago, condensed matter physics was my background. Dan was on my thesis committee, however many years ago. So that's sort of what led me to be here and how I function within this community.
Thank you. And Yustina, you have some slides that I will share.
So I come from the semiconductor quantum dot community, so just a subfield within the condensed matter physics. And for us, so the research I've been doing are focusing on automation of experiments, quantum dots, and also other experiments. And for us, reproducibility might have a little bit different definition. It's not necessarily reproducing the experiment that others did, but more reproducing the behavior of an algorithm on data that comes from different experiment. Because for us, for something to be consistent, for a method to be consistent means that it should work no matter what device we're going to use to deploy our algorithms on. And in order to test and compare the performance of those different methods, we need data. And unfortunately, within our community, it's still a common practice. As you can see here, there are two papers in the top showing that the data is available upon reasonable request from the corresponding author. And sort of in our group, we have the opposite attitude. Whatever data we use in our papers, we try to make available, whether it's simulated data, whether it's data coming from experiments. We don't necessarily make available raw data because the experimentalists don't always want to include all of the metadata in them, but everything that we need for our algorithms to be tested is included in the data file. But like I said, this is not really a common practice yet. And then if you start looking at papers, there's a lot of papers saying like, oh, our tuning method has 67% success rate, ours has 98, but then what does it mean and which one is better? There is no really common metrics that we could use to even determine whether these results are consistent or not, because they are tested on different devices, different, like I said, different algorithms, and nothing is being shared. And so can I get the next slide? In last year, we decided to put forward a Federal Register notice to call the community to report what data is available out there related to the automation of quantum dot experiments. And then that was in April, I believe. And then in July, we had a workshop where we invited stakeholders from industry, from universities, from government, from labs to come together and discuss not the glorious results, but what is missing, what is needed, what needs to be addressed in order to make the research reproducible in a sense that I can take my algorithm, test it on your data, and see that it actually does perform better or not. And what we found at the end of the workshop, we had also working groups just like here. And what we found is that the community wants to share data, but they don't know how, because there is no guidance of what should be included in the data. Because like I said, they don't necessarily want to include everything, but we also don't need everything for our purposes. And there is no standard data format. There is no standard platform. There is no one who would oversee that. And can I get the next slide, please? And so we came up with this figure showing how, in order to enable reproducibility for our community, how the different parts come together, that we need to have theory and computation simulations and experimentalists work together to produce the data, because we need data from simulation for training machine learning algorithms. It's unfeasible to use experimental data because the data typically needs to be labeled, and it's just, you don't want to do that. But we need guidance for how the data should be prepared before sharing. We need some kind of governance and licensing that would tell who owns the IP rights to that data. And then we need to establish performance metrics that will tell us what is better, what is worse. And then we need to have test beds where ideally all the data would live. And if someone wants to go and has new algorithms, they can test them on that data, or they can pull the data from there. And there's like a repository, not just of data, but perhaps codes, perhaps access to actual devices. Maybe we can have some devices available to the community so they can test their tools, whatever they are developing. And that would definitely drive the reproducibility, because if we all develop new tools and then we test them on the same system, then we can confirm that our tools work as expected, and we can confirm which is better than other. And so right now we are waiting to see what is the actually active response from the community is going to be, because someone needs to take the leading role in establishing the working group that can oversee the database establishment and the development of all the other components presented in the figure.
Thank you. And Dan?
So I have no expertise in this. So they needed 5 people on the panel. So they just picked a typical physicist to sit up here. So that's what I'm doing. And I was very naive until the Hendrik Schoen case came up. And then that was a rude awakening. I always believed in a community that we were always after understanding and trying to understand how the world works. And then I realized that was shown that people went too far in trying to do that, mostly driven by the rewards that would come from doing something flashy. I have had, after that, when my eyes became more open, I started watching more carefully. Most of this meeting has been about fabrication, the fakery. And what I've seen lots of since then is, in terms of irreproducibility, is a lack of detailed understanding of what people do in their experiments. 3 times in my career, I've told a community that they were doing something wrong. 2 out of the 3 times I caught hell for it for more than a year. Eventually it came out okay, that I was believed, but it's a lack of what I see is data and claims that are made from a lack of an in-depth understanding, from actually being critical in how you do your experiments and how you analyze the data. And I would say that right now, that's a bigger problem that more larger, maybe not larger, but more extensive problem than data fabrication or the other things we're looking at. Well, okay. So I'm sort of random. That's it. So I was on POPA, the panel on public affairs, as the American Physical Society was developing its position on ethics, the ethics document that's out there now. So I certainly added a lot in there. One of the things that, at least in that document, that I was tried to get in, is that one of the things that I do see is, in my opinion, is a lot of cherry picking of data, that people are very selective in what they decide to publish. Since I've been nudged on this, if you could probably tell if I refereed your paper, because in there I'll ask you, how many samples did you measure? And were the results consistent from all the samples? Because I think we see a lot of where people report on 1 or 2 samples, which out of my lab never happened. Well, that's not quite true, but if there's a easy way or a way to manufacture many samples, I tell students we have to have a dozen samples that give us the same results before we start thinking about it being real, right? So anyway, so that's that.
All right, thank you. So those introductions were wonderful, touched on a lot of the topics of the conference and of this panel. So I'm going to ask you a few questions. You can take them in any order you want on the panel. And some of it might be subjective, but I think it's good to get a sense. I want to start with, how prevalent do you think this sort of unreliable research or irreproducible research that we've been talking about is actually? I know that may be subjective. Maybe we don't yet have sort of more objective ways of detecting them, but I want to get your view on that.
I can say something first to at least get the discussion started, because I think there really isn't much of a quantitative answer. I believe it was Igor stated earlier about sort of, there was a discussion of experiment and theory, is there really a difference? And we don't quantitatively know, but I'd say order of magnitude, I agree with what he said. There's no reason to think they're different. Now, what I can say from where I sit at OIG, I recognize that plagiarism is not fabrication or falsification. Nevertheless, it is something that can be measured and detected in a much more quantitative way. And in the last 10 years, my office did it. They were both prior to me being there, 2 different studies. One in which they looked at, they reviewed every career proposal that was submitted within a 1-year time period for plagiarism. and found that at the level of funded, plagiarism was in about 1%. Unfunded, it was closer to 6 to 7% of submitted. Now, again, that's plagiarism. I do think plagiarism is more common. It's a heck of a lot easier to do. The other thing that I would say to that, in a sort of at least nudging towards quantitative, where I sit, where I see the allegations coming in the cases for all fields of science that NSF funds, no field of science is really a standout as best or worst. You know, there are definitely differences in how these things manifest in different fields, but we really don't see any one field standing out. Ultimately, every scientist in every field is a human, and that seems to be what the sort of dominant origin is.
Maybe I'll just say
Please.
something about that, because I want to emphasize the spectrum that I sort of touched upon earlier. You know, I'm shocked just at the number of times I've tried to reread my own papers I've written, not my students. And I've left out a parameter value, or I've left something out which renders the thing irreproducible, right? And that's a one end of an innocent end of the spectrum, where there's too much literature out there that's just not reproducible for not for, you know, big reasons like fraud, but just inattention to detail in my case. And then, you know, that's one end of the spectrum, but all along the way there's maybe information that maybe authors even consciously decided not to disclose. They didn't violate anything, but, you know, it's going to make it really tough, especially in the case of experiments, to reproduce that experiment. And I'm hoping that this group can address that middle of the spectrum a little bit more. The fraud cases are, as I've said before, a bit of a distraction, because that's going to happen as an anomaly, and it's not what we expect. I'm with Dan. It's just shocking when it happens, and I didn't really become aware of it until the Schoen case. But it's the middle of the part that I think we want to be able to address there. And so then the answer to the question is it's very prevalent. It's kind of a little bit embodied in the way we do things, because we like to write things in code, acronyms, you know, the whole bit. It makes it more difficult to reproduce things.
Maybe about this middle of the spectrum, for me, this is largely about biased data selection and cherry picking of data, of real raw data that was measured in real experiments. In a way, what I presented earlier, the nanowire work is like that. There's some bits and pieces, I think, that go beyond that. And I don't know a number, but to answer the question, I'm under the impression that in my subfield of experimental electronic nanodevices, it's just the tip of the iceberg. I can see it left and right superficially, that I think, well, could I look at the full data? What would I really find in these papers? And it's just a matter of bandwidth and expertise that I turned my attention to this particular topic. Yeah, I can think of tens of other projects that I could start and undertake, where I suspect I would also find that the claims are unreliable. The science is not reproducible in those works.
Right. So I think that there's a lot of literature out there that's difficult to reproduce, but it's not intentional, right? It's like you just leave something out. It's you don't think it's important, whatever it is. I think it's hard, but in my career, I'm excited when somebody calls me and says, "Oh, we've been trying to do what you did and we're having troubles." It's because it means they're interested in what I've been doing, right? So I'm happy to exchange emails and work with them until they finally get what they're after, right? So it's, I think that if the community is of a mind that the science is more important than egos or than reputations, that people are willing to work with you because we all want to get to the end of the road. We all want to see what's giving us the light at the end of the tunnel, so to speak, right? And that should be the thing that drives us. And sometimes the other things get in the way of that.
Thank you. Any other comments, please?
I think that another problem, even if the data is not changed and it's like a actual real data, I think there's a little bit of a problem of overstating what was really done and what was really accomplished, which is it might be done because in order to get to the top journals, you have to say you did something for the first time ever and you did it on like so many devices and it worked perfectly. But then when you go and look into the paper, you see that it's, it's in the abstract that it was shown on 5 or 10 different devices, but in fact, it was really tested on 2. And there's maybe like 1 measurement from each of the other 8 devices, but this is hidden unless you go to the supplementary. And I think that is also a problem that not everyone is honest in the breadth of the work they did that they're presenting in the paper. They're trying to make it look like it's more than it actually is.
Thank you. So we've touched on some of the issues like, how you came to know about some work that was unreliable and, the prevalence and so on. But I want to learn a little bit more about your experience of what, how you approach that. We heard from Frank, for example, that maybe he started doing that reluctantly. And also, what did you use to facilitate your work? And that has the point of, what kinds of tools we really need that are not there yet to facilitate this sort of checking and verification work.
Yeah, as far as the tool, I mean, the main thing is raw data. That you're pretty lost without raw data for experiments.
Agreed. I think it would be extremely helpful to also get descriptive pieces as well. So contemporary logbooks, notebooks, perhaps intermediate analysis that were used internally. Doesn't need to be post-processed and polished, can be the raw documents as they were made at the time. But I think this is very useful to help reconstruct the workflow at the time when the experiment was undertaken and to understand how conclusions were being reached. So call it metadata or analysis internal, but I think a level of that is extremely helpful if that is being shared too.
Okay.
On our end, we did make first publicly available data set. We posted it on data.nist.gov, so everyone can use it. You don't have to log in or anything. You can just go to the website, download the data. It has supplementary documentation explaining everything about the data, like what was measured, what was for experimental data, what was measured for simulated data, all the parameters that were used in the simulation to get the data. We provided links to all the papers that used in one form or another that data. So, and then we organized the workshop so that we can bring community together to discuss the issues that are out there that needs to be addressed in order to enable the reproducibility. So we're trying to do our fair share of the job.
All right. And is there any sort of tools or infrastructure that you think should be developed, especially if we are dealing with large amounts of raw data or, scripts or anything like that, that would make it usable and tractable and so on? That is lacking right now.
Yeah, I kind of commented on that. I think in my intro that I feel that we are lacking an integrated tool, and I'm not asking for the next sort of like obscure software that gets lost. But I think we should think about is to set up standards of data, of code, of analysis, etc. How this can be logged on the fly, so students get basically trained up upon entering a lab, and as they go along, this gets logged real time. And I think it will just also be very practical for paper writing, thesis writing, etc. when this is done in a more standardized and systematic manner across the board of the various outputs we generate. And I don't think this exist yet. We don't have the standards yet, nor the tools. The technology, I think, of course, exists already for many years for it.
Mhm. Dan?
I'm not sure that it's something that needs to be developed, but it's something that needs to be reported. I used to do lots of force microscopy a few decades back. And whenever we first started doing it, when the student brought me an image, I was amazed at what he showed me. And I couldn't really decide if it was reality because of all the image processing that went from the raw data till the final picture. And a lot of the data, rather than some way to analyze it, you need a very clear roadmap how you started from the raw data to produce that image. You know, did you do thresholding? Why did you decide on that threshold? How did you decide anyway, lots of things that go into it. So the recipes, maybe more than a formalism, are critical.
But I would iterate again what Dan said earlier, which is we don't, you know, in some ways, special tools are not required. If I can send an email to somebody and receive the raw data and basically a roadmap of how the final results in the paper were achieved, that is sufficient. And that happened in one case. So we did write a comment on a paper, actually was co-authored in part by my former supervisor, PhD supervisor, and by a longtime friend and mentor. And it was that, and of course, the supervisor was already dead, but that mentor was fairly upset. But he sent us the raw data and he sent us instructions on what he had done. And then it was crystal clear. And we were critical of his result, and they responded in a formal comment and reply. But the process worked because there was that exchange of information. And like Dan, I myself have been just thrilled when someone emails me and wants to know about what I've done, for the simple reason that you say, wow, somebody's actually looked at my work. I feel great. So I wish that, so I never talked to people informally like that for the first 20 years of my career because I wasn't trained with that culture built in. And maybe that's something we should tell our students more, that yeah, they should just feel free to contact people when they need more information than what's in a paper, because it's always going to be lacking for some reason or other in the paper.
One comment really focused more on the norms and standards than the technology infrastructure is just, as I look across fields of science, I do see specific successful examples of fields sort of improving their internal communication. There's been a lot of talk about cherry picking, like reporting number of samples. That sounds very similar to what I've watched play out in the behavioral sciences, where there's been just a growing trend of, they often p-hacking is what's an issue there, but exactly what gets communicated amongst scientists as science is happening normally has become much more explicit within that community. I mentioned chemistry when I spoke earlier, has very clear standards about what different measurements to what accuracy levels are expected to be reported. Many fields of biomedical sciences that are heavily dependent on imaging have stated standards that relate to those, you know, what Dan was saying earlier about the image changing parameters. I don't even want to use the word manipulation of what's acceptable or not. And I do think those sort of making those norms explicit does go a long way to the sort of good practice of science and the reproducibility. I tend to agree that the bad actor that is hell-bent on carrying out a bad act is probably not going to respect those written norms. There are other processes to clean that up. That tends to be where my office comes in. But I do think those explicit statements of standards and expectations, even if they're in very narrow areas, do get traction and do become the norm and do help.
Thank you. So my next question is more about your own sort of experience with various entities that you have interacted with, starting from universities and institutions, but also journals and funding agencies and so on in the work that you've done on reproducibility, either to develop methods or norms and standards, but also specifically about looking at cases where there has been a problem. So what is your experience working with these different entities?
Well, Vincent recounted his quite nicely in his talk, and I have, as I mentioned, I have not dealt with the fraud case, but I can maybe talk on behalf of my collaborator, Jorge Hirsch, who did deal with this, has tried to contact everybody under the sun, all the way from the people doing the science themselves, their institutions, the journals, the funding agencies, even the office, I think that Beth is related to, that is supposed to look into these matters, and got zero traction. Okay, and basically, in the end, writing about it in the literature is actually not the preferred venue, and I don't think it was his, but there was no choice in the end except to go that route. So again, in this group, maybe we will try and recommend things that can make this procedure a little bit better than what it seems like several people here have experienced in the past.
Okay. Anything else to add?
I don't think there's a recipe. If I were confronted with this, if I were to discover fraud or fabrication of data, I don't know how I would proceed. I guess I would start out with talking to my colleagues at the university to see if anybody had any ideas, but it's certainly not publicized how you would proceed. There's not, for the APS, we have a code of ethics, but it doesn't tell you what to do if you find somebody violating that code, right? So a path to finally get to the end of it is not at all clear, and it's one of the things that I hoped would be coming out of this meeting, that we're in at least the beginnings of a path to be able to follow.
Yeah, I can fully endorse that. That for us, it was really completely obscure and unknown how to proceed. We had to find this out on the fly, adapt, and I still don't know what is the right or the clearest pathway. And I don't think there's a golden bullet available to us at this point. And I think this would be extremely helpful if we could streamline this process.
Thank you. So I have a couple more questions, but I want to see if there are any questions in the room or online. I see Igor's hand up.
My question is to Beth, who mentioned earlier about plagiarism, which is a aspect that has not been touched upon in our conversation earlier here. And I was thinking about that, and I think that there is plagiarism and plagiarism, and they're might be very different. And a friend of mine found completely randomly through some random literature search his own paper, verbatim, published by unknown people in something called a Nepalese physics journal. That's plagiarism, definitely. Not particularly damaging, that is. But then there are cases when, okay, let's say I'm a young scientist, and my supervisor asked me to write an introduction to our paper, the ontological Hall effect. That in the introduction, I must introduce the concept of scholar spin chirality, which is not very well known, but of course I didn't invent it, my husband didn't invent it, but it's really helpful to put it in. Now, I'm not even a native speaker, I'm not a good writer, and there are 5 previous papers which did the same thing. So what is really wrong is just taking their words and putting my paper. It's not stealing, it's not work. I'm just easier for me to write my introduction. Or another example, you may or may not know that former Harvard president Claudine Gay was accused of plagiarism. And I actually look into what the accusation was. It was something on the level that she writes that whatever, Smith and Wesson claim in their paper that, and then there is a verbatim citation from Smith and Wesson. And she didn't put it in quotation mark. The program flags it as plagiarism. Come on.
Sure. So I'll say a few things while maintaining that there is no acceptable level of plagiarism. The regulation also specifies a sort of the significant departure from accepted practices. And I do think there's times that small amounts happen that we would characterize that as a departure, but maybe not a significant departure. So, that's one response. Particularly in the context of, say, material being proposed to NSF, our focus is really on, does everyone involved in the merit review process, program officers, do they have all the information about truly the origin of that proposal? And I'd say using definitions, using things that have been written before, cite it. I don't have any, I don't know of any problem. There are no restrictions on citations. And so, I agree that these things can run a huge gamut. And we try to behave with discretion. I would also note that institutions where ultimately, should something reach an investigation, that occurs at an institution. The one thing often when it's an educational institution, I will say we do expect, if there are standards for this that apply to, say, their undergraduates in educational standards, it's appropriate to apply them in sort of the writing across. These are in general sort of community norms. They are not chiseled in stone. They can change, but that is sort of where things stand now.
So perhaps coming back to Igor's example, I guess if you're quoting a definition that can go in quotation marks, it sounds like, right? That would not then be plagiarism.
Yeah, what I can say is certainly if material is quoted, cited, and referenced, that is not plagiarized. I acknowledge that sometimes it's, cited and referenced and not quoted. I can tell you, we're really not in the business of opening cases when that is the issue. As I said earlier, these issues co-occur way more than I ever would have guessed. And, once there are a variety of issues, we tend to sort of count up everything because we don't really know where the situation's going.
Thank you. Other questions in the room? Yes.
One of the things I should say from the outset is I fully endorse the whole idea that's been discussed multiple times about making the paper a richer, a more complete reflection of the work that has been done with it, whether it's the data behind the work, whether it's the code, whether what have you. And in the event of publication, that can surely only benefit reproducibility going forward. My question, and I'm saying this without prejudice one way or the other, is do you feel that this potentially changes the burden or the expectation on the reviewers of those papers, particularly as, in addition to the pressure to publish that authors experience, from a publisher's perspective, there's also the pressure for speed, and this pressure is driven by the community itself. Are we running the risk? And again, I don't have a strong view on this, but I'm just posing it as a question. Are we running the risk of increasing the burden on the reviewers? This is something we have to worry about as the volume of papers we have to process goes up and up and up. And by providing them with that information, okay, it's information, it's there for them to access if they need to during the course, or they feel they need to during the course of the review. But are we raising the expectation that the reviewers will do more as part of the review process and hence have to work harder at the review process?
I can give an answer to that. I think it's going to help the reviewers, if anything. And I take the attitude about including this information in a paper the same way I treat thesis defense, right? So when I'm on a committee for a thesis defense, I have to read a sometimes 300-page thesis. And I'm always reminded of the words one of my professors told me when I was a graduate student, which was that he actually told students that he didn't care how long the thesis was. It could be as long as they wanted it, as long as they told him which 100 pages he should read, right? So what I would say is for the thesis is put all that stuff in an appendix. And people like me, if it's a theory thesis, I actually like to see the equations and maybe even work through some of them. I'll look at that. The other reviewers won't for that thesis defense, and that's fine. That's not going to, and I don't think at all that they feel any pressure that they should read it because it's there in the appendix. So I don't think that's going to be a problem.
I also think it depends on what is exactly included with the paper. If it's just the raw data that the reviewer then has to figure out how to access and process and analyze, then that will definitely put extra burden on them. But if in addition to the data, they are provided with a code that will help them get from the raw data to the final figure, for example, in the paper, then I think that's not going to really cause that much work, but it will make it will allow them to make sure that the figures are not manipulated with, because they have the raw data and then they can reproduce the final figures themselves.
Yeah, I guess my question though is partly by providing that information, is there a sort of now an expectation that the reviewers need to do that check, need to do that work?
And I guess, are you also asking where that accountability or responsibility would be placed, or?
Exactly. I
Yeah.
guess, sorry, since I have the microphone.
Sorry, yeah.
Because what can happen is, because we provided these materials and the paper is still published, it means it's all fine, right? So that in that sense, it's not about the burden, but it's about, oh, that's already got all verified, right?
Right.
So but I think that can be sorted out.
Any comments on?
I did have a question, but if you want to address that.
Yeah, I'll just acknowledge that I think that's a very valid perspective. In particular, what Seradjeh just said of, if the material is explicit in the paper, what then is the interpretation? And I'm sharing that because from where I sit, we sometimes get, I'm thinking of one case where the allegation was that the key findings were, I'd say, inflated to the point of falsification, and the allegation hinged on a particular type of imaging wasn't reported. Well, when I looked at the full paper, and this was in the body of the paper, it's true that that image was not there anywhere, but the method section stated that the image process, that image mechanism had been done. And that definitely led to us looking at saying, okay, this is a matter of sort of peer review and scientific literature. The person revealed that they did conduct that experiment. It's not there, but that was well known. I mean, it's not like something's being concealed or altered. And so I do think working through the implications of that is a very, fair perspective.
Ultimately, the more information you have, the better you are apt to make a good decision.
Mm-hmm.
And maybe to follow, again, the notion that, we're better off by covering our eyes. Okay, now we can't see it, so now we're not responsible for it. can somehow improve the process doesn't make sense, right? So if it's there for someone who might check, and you could think of it as a, you know, as a random audit, right? We all fill out our tax forms knowing that we can be randomly audited. So we kind of do a good job. Maybe we'll do a better job with the papers when the information is all there and we know somebody can just look at it and check up on it rather quickly.
Yeah, and then
That sounds
in any case, I sort of object to the whole idea that once it's published, it's set in stone and it's like a holy document. And come on, it's like all of this can be done afterwards as well. We should normalize correcting, maybe even expanding, even retracting papers after the fact. Like, who cares? It's 2024.
Mhm.
Just that expectation might shift a bit.
So perhaps you can at least put a duty on a reviewer to check that all the material is there, and not necessarily not necessarily check its integrity or quality per se. But yeah, we can think. But this is something. I think this is a discussion to be had.
Yeah.
To be had.
Okay.
Yeah.
So I want to take one more question. I think it comes from Seradjeh, and then we'll try to
abuse my microphone holding privileges. Riffing off of several topics here, the extra burden, the fact that the examples in some of the talks were sort of extreme cases and coming from high profile fields of science and condensed matter physics. A lot of the people in doing this kind of work I know them and they're my friends or former friends anyways. And I talk to them and I hear this kind of line of thinking, which I want to run by you. So somebody formulated very succinctly to me just last week. We are after huge goals, you know, room temperature superconductors, qubits that work. If we reach that goal, it will be self-verifiable, right? Like it superconducts. The benefit we bestow on human race is so huge that all the little inconsistencies and errors, it's not worth checking. It's in the denominator. We can just forget it. At the same time, if we don't reach our goal, that's also not worth examining those errors because it was worth it. The chance that we would discover something was so huge. And yeah, now we can just move on to some other big goal. You know, we cannot be distracted by going back and rechecking all the things that were said, that all the things that were claimed, right? So in this meeting, we are all, you know, I bias selected people that are here to be all on the same page about like data sharing, right? But so we all say, yes, it's important to check for errors, but what if it's not? Maybe it's not important to check for errors. Maybe it's just it's a drag. It's a waste of time. Thanks.
You could generalize that and just ask how many papers are published that are relevant. Okay. I mean, I've had conversations with colleagues back home that if you look at BCS superconductivity, starting from 1911 up to BCS, how many papers were relevant to get to that goal? How many did you really need out of all the papers that were published, right? So that's sort of along the same lines of what you're saying, right? Where's relevancy and what's needed and what's not needed?
Okay. Any other comment?
I mean,
I don't have
Obviously
friend
wanted-
calls.
you obviously wanted to be provocative, but it's yeah, but sorry, what was I going to say then? I mean, think of the damage some of these things have done in the public eyes, and for that reason alone, there has to be some scrutiny. There has to be some activity on our part to monitor what we do. Otherwise, we lose, for the simple reason we would lose what little trust we already have.
Plus, plus these false flags will misdirect research and quite possibly make reaching the big goals more lengthy and more difficult. So they're not only irrelevant, but they may actually be negative influences.
Yeah, I was just going to add the same thing of, resources are limited. And that's both the resources to check, but also the resources of pursuing science. A question that I got once internal at NSF was someone basically saying, science is self-correcting. Why do we need this? And my answer to that is science might be on a long enough time scale. Scientists aren't. And on the time scale, individual scientists, it is a human activity. I've heard a lot of like, oh, that's the sociology of it. But the time scales are different. I don't think we have the resources, the patience, nor should we, for the kind of, well, eventually it'll sort itself out. We have limited resources now. We're working now. The careers and time spans of your students, that can easily be 2 to 5 years. Like, it's not fair to them to say like, it'll come out in the wash in 100 years.
Yeah, I fully
the
agree.
time scales are
I find that a very, very cynical and inhumane view actually towards the young generation to have the idea that science is self-correcting. So why bother?
Yeah, if just one last thing, and I really will stop. Like, science is hard enough as is. I mean, people are really working on challenging problems. There's enough reasons that things are going to go awry just because nature is really, really hard. Catching the sort of unforced errors, the humans, is just, I'd say, straight up the prudent thing to do, particularly when public resources are being used.
Thank you for all good comments. I guess from my side, I will also add that for science to be self-correcting, we need to be part of that self-correction mechanism. This is part of it.
It's not passive.
It's not an abstract thing. So with that, if there are any final things you want to add, I will invite you to do that. And like, in view of the hour, maybe we should stop here. So thank you again, and thank you, everyone.